In the continuation now, we are going to solve question number 81 of my booklet. It is from algebra, ring theory. It is 85 of booklet A and 82 of booklet C. Here I have written something in advance to save time. That given R is a finite non-zero commutative ring with unity. Two things are important. It is non-zero ring, it is commutative and with unity. So R is CRU and R is not equal to 0. So let R equal to A1, A2, AN, and where 0 is kept separate. It is finite. And then which of the following statements are necessarily true? Now let's go for analysis of the options. First statement, any non-zero element of R is either a unit or a zero divisor. Let's go for some proof. Let A is any arbitrary element among this which is non-zero. So it is among this. It is a non-zero element. Suppose A is not a zero divisor. It means the product of A can be 0 with any element if that element is 0. So if AI is non-zero, I take element here only. So A dot A1, A2 and so on, AN, they all are non-zero element. If any of these two product, suppose I write here, if A dot AI equal to A dot AJ, this implies this. Now again, by this property, if A is non-zero divisor, then this has to be 0. This has to be 0 means AI equal to AJ. So all these products are distinct. They all are non-zero. So they are among here only. And as it is given, it is commutative ring with unity. So there must be some element AR belongs to R such that A dot AR equal to AR dot A equal to 1, which is unity, and AR is among them. This implies A is a unit. So either element is a zero divisor. If not, it has to be a unit. So option 1 is correct. Option 2 says there may exist a non-zero element of R which is neither unit nor a zero divisor. Obviously I have proved here, so this cannot be correct. And third statement, every prime ideal of R is maximal. In a finite CRU, it is clearly mentioned, in a finite CRU, every prime ideal is maximal, and even converse is also true. In any CRU, we know maximal is prime, and in a finite CRU, prime is maximal. This is very fundamental statement which we keep on remembering. And fourth, if R has no zero divisor, then order of any additive subgroup of R is a prime power. If R has no zero divisor, that means it is commutative ring with unity without zero divisor, which is integral domain, and we know every finite integral domain is field. So it is field, and once it is a field, we have another result. The cardinality of finite field is always of the form p to the power n, where p is some prime. So it says R has no zero divisor, then order of any additive subgroup of R is prime power. Obviously F plus, the subgroup of F plus has to be, the order of subgroup of F plus has to be divisor of this, so it has to be of prime power. So correct options are for this question 1, 3 and 4. 1, 3 and 4 are correct for this question. Thank you.